Hey y'all, it's that time again. It's Math with Mrs. Peters, the crazy cat lady of Hiram High School. Today's topic, function composition. Now first we're going to look at a couple of functions. I have function f here of x, which is x squared plus 3x minus 2. Then I have function g of x equals 3x plus 8. And I have function h of x equaling x minus 9. All right, now what I want you to pay attention to is with f of x, the only part we're actually going to be working with or computing with is this part here, the part to the right of the equal sign. Okay, with g of x, the only part we're going to deal with is 3x plus 8, and with h of x, we're only going to be dealing with x plus 9. These are the parts we're going to do. Now, let's talk about function addition. Okay, function addition says I take f of x and I add it to g of x. Well, what does this really mean? This means I'm going to take that part of f of x that I said we were going to work with, and I'm going to add it to g of x. Notice the use of parentheses here. Y'all, those things are going to be helpful. You're going to have to remember to use parentheses. Now, when I remove parentheses, I get x squared plus 3x minus 2 plus 3x plus 8. I want you to notice I've already underlined a set of like terms, and those become 6x. And then negative 2 and positive 8 are also like terms, and when you put those together, I get positive 6. And the x squared that I haven't any like terms with is just brought down. And this now becomes our answer right here. Next, let's talk about function subtraction. Okay, function subtraction says I'm going to take g of x, I'm going to subtract h of x. All right, well, let's put that little pay attention to what's between your parentheses. So I'm going to take the function g of x, and I'm going to subtract from it h of x. And when I rewrite it to remove the parentheses, I have to remember to distribute the negative sign, and I get 3x plus 8 minus x plus 9. I have a set of like terms, 3x and x gives me 2x, and then 8 plus 9 gives me 17. And here's my answer right there. All right, now let's talk about function multiplication. It says f of x times g of x. Again, there's nothing between the parentheses, meaning I'm going to multiply. So f of x is x squared plus 3x minus 2. G of x is 3x plus 8. And I'm going to use the box method, and I do love that box. So f of x is on top, g of x is on the vertical side, and as I go ahead and build my box, I start doing my multiplication. 3x times x squared is 3x squared. 3x times 3x is 9x squared. And 3x times negative 2 is negative 6x squared. Guys, make sure you notice right here that though I said 3x squared, I really meant 3x cubed. Okay, 8 times x squared is 8x squared. 8 times 3x is 24x, and 8 times negative 2 is negative 16. I collect like terms. Now remember, if we're lucky, we have some like terms happening on the slant, and that's really handy. And so when I collect my like terms and I do my rewrite, I get 3x cubed plus 17x squared minus 18x minus 16. Now let's talk about function division, which is the new thing that we just learned in Unit 2, Part 1. We have f of x divided by x, or we might see it written this way, f of x divided by h of x. F of x is x squared plus 3x minus 2, and we're going to divide by x minus 9. Okay, we use our little template here. Okay, 9 is my divisor, positive 9. My coefficients, 1, 3, and negative 2. Bring down the 1. Okay, then 9 times 1 is 9. Okay, bring that 1 down there. 9 times 1 is 9. Add them together, we get 12. Okay, 12 times 9 is 108. And 108, subtract 2 or added to negative 2 is 106. And my answer is 1x plus 12 plus 106 over x minus 9. Here comes the new material, guys. We're going to talk about function composition. Okay? That means when I nestle a function inside of a function. Sometimes it will look like f of g of x, or I like to call it fog. This symbol right here with the open dot means a nestled composition. Here it is in color to help you see it a little better, but I'm putting the function part, remember the part that we're using, inside where the x's are in f of x. Okay, so with that said, here's f, okay, x squared plus 3x minus 2. Every place there is an x, I'm going to put a set of parentheses, okay? The x's became parentheses. Inside those parentheses, I am putting g of x, right? Now, I'm going to expand this where I have my 3x plus 8 twice, because that's what it's squared, and then my 3 times 3x plus 8. Okay, I do my multiplication. Then I'm going to collect like terms. I'm going to collect my x-like terms. And I don't have anything to add 9x squared to, so I get 9x squared plus 57 plus 57x plus 86. So with that said, my answer is this one right here. Now, one more. Let's look at another function composition. Let's look at g of f of x, or g of h of x. Okay, it says I'm going to take the x's in g, and I'm going to replace them with the function h. So I rewrite g, so I have a big set of parentheses where the x would be, and inside where that x is, I am putting h, x minus 9. Okay, do the multiplication. Collect like terms. And your answer. Some of these will be long, some of them will be short. But you can do it. Now, what I want you to do on these notes is I want you to try to do f of h of x and h of g of x. These are two separate problems. Just give it a try. I know y'all can do it. I'm proud of you. Take care. Have a good evening. Bye-bye.